Hey guys, it's Miss Hageman. This video is going to take you through the slides on OST practice, area, circumference, and volume. Okay, you want to make sure you click on these two links on the first slide. One of them is going to open up your reference sheet that you'll be getting on Wednesday, and the other is going to open the calculator that you'll be seeing when you take your geometry OST. So make sure you click on these links to use during this assignment. All right, so the first slide, before finding the area, we're going to use the Pythagorean theorem to find the height of this triangle. Okay, so the sign company wants to know the area of this triangle, but we need to find the height because if you look at your reference sheet, the area of a triangle is 1/2 the base times the height. So in order to find that, our base is 10. And if we're going to find the area of each triangle separately, the base would be 5. So this side would be 5 here, and this side would be 5 over here. And so in order to find the height, remember we have 90 degrees, so we have A, this is our C, and we have B here, okay? So if A equals 5 and C equals 13, our shortcut would be, if we go to our Desmos calculator, to do the square root of 12 squared minus, let's double check over here, I'm sorry, 13 squared minus 15 squared. And so 13 is our C, and we're going to take away the side squared, and we're going to see that the height is 12. Again, this is a shortcut for Pythagorean theorem. You're going to do C squared minus A squared, take the square root. So this means that the height of the triangle is 12. So with the height being 12, now we're ready to find the area of the height is 12. The area of the triangle is going to be 1/2 the base, which you can do 5 times 12 and then you can double it, or you can do the base of 10 times 12. And so the area of the sign is going to give you 60 square feet. So our answer to the first slide is 60 square feet. Again, that was 1/2. The base of the sign is 10. You could have also used 5. 5 times 12, and taking half of that is 30, and then you'd have to double it. Okay, so the area of the sign is 60 feet squared. And our next one, triangle ABC is shown. Which three-dimensional figure results from rotating the triangle 360 degrees about line AC? Okay, so this is multiple choice here. We do have a triangle here. So when we rotate this, we need to select a three-dimensional shape that appears to have a triangle in it. Okay. So a sphere is a circle, so we're going to eliminate D. A cylinder does not have any triangles in it. A cylinder is a sort of like a Pringles can. Okay. So the ones that would make sense here would be a cone or a pyramid. And so you want to be able to narrow it down to A or C. And so if we rotate, I'll just try to draw this real quickly here. So if we try to envision this rotating 360 degrees around, this is going to kind of make a circle here as the bottom, around AC. And then this is going to be a series of triangles. Okay, and excuse my drawing. And so we're going to have a series of triangles that is going to be going up to C. And so this is going to appear to be a cone. A pyramid has a flat base instead of a circular base. So a cone is going to be your answer for slide 3. All right, a cross section of a right triangular prism is created by a plane cut through the points shown. What's the most specific name? So the most specific name is not just a parallelogram. Okay, a parallelogram is very general. Okay, so because it says specific, we want to eliminate parallelogram because a rectangle is a parallelogram, so we want to get rid of that. So if you said parallelogram, you might be thinking rectangle here. If we're slicing this through the points shown, it's called a cross section. We're going to slice down, and we are going to be making another rectangle through the center here. So this is going to be B, rectangle. Okay, for those that selected triangle, you might have been thinking that you're going to slice it through the center horizontally, but we're going to be slicing it vertically up and down. Slide 5. This one you're going to use a calculator for. Find the volume of Jupiter. Okay. And then once you find that volume, you're going to do a percentage of that volume for Saturn, and then we're going to undo it to solve for R. So our volume for Jupiter is going to be, go to our reference sheet, the volume of a sphere is 4/3 pi r squared. I'm sorry, pi r to the third. And so this is what we're going to type in the calculator, 4/3 pi r to the third, to find the volume of Jupiter. So we do 4/3. And then we can just use 3.14 for pi. And I'm sure you can do that on your state test as well. And check our reference sheet, and we're going to do the radius to the third power. And so the radius is not actually the entire distance. The radius is half the diameter. So we're going to divide 142,984 by 2. And so we're going to be using in our calculations, we're going to be using 71,492. And so we have our volume of Jupiter. Again, the radius, and we need to take that to the third power. Sorry about that. There we go, to the third power. So notice we hit the A to the B button. Okay, that gives us the third power. So that's a very large number, 10 to the power of 15. That's called scientific notation. So we're going to keep that answer, okay? And now we're going to take a percentage of that answer. And so from the number that we have, we're going to multiply this by 0.599. We're going to keep it all in the same row. We don't want to retype it or copy it. We want to keep it all calculated together. So now this number here is now the volume of Saturn. Okay, and now we're going to solve for R. We're going to undo this. Okay, so if this is the volume, we're going to have to take this large number and we're going to have to divide it and undo what it says on our reference sheet. So we need to get rid of the 4/3 and we need to get rid of the pi. And then that's going to give us a radius. So we're going to divide this by 3.14. And we can actually delete this. That's dividing by 3.14, which is canceling it out. And now we're going to divide out the 4/3. And so the number that we have, we need to take the third root of that to get the radius of our, so to get the third root of this large answer, we need to use the third root button. And to do the third root, you'll find that under, you're not going to use this one. This is square root. So you're going to have to go to functions and go to miscellaneous. And it's going to be the root with the n on it. You can also do this on the calculator that they provide to you during the state test as well. So we're going to open a new cell. We're going to type a 3 here. We're doing the third root because we're looking for the radius to the, we're trying to undo to the third power. That's why we're doing the third root. And then we are going to have to copy and paste this underneath here. And so this number here is now the radius of Saturn, and we're going to need to double that to be able to find the diameter. So we have to multiply that by 2. So times that by 2. And so this is our answer for, I know it's a lot of work, but this is our answer for slide 5. And it should tell us how to round here. Round your answer to nearest thousandths. So nearest thousandths, tenths, hundredths, thousandths. So there we go. So that is our diameter of Saturn. Population density, you're just going to do people divided by square miles. So we're going to do 7,112,688 divided by 426.25 square miles. And believe it or not, this is a question, maybe a question on your state test. So the population density rounded to the nearest person, we're going to round down because we don't exactly have that. So this is going to be 16,687. So again, anytime you're looking for population density, it's people per square mile. Just make sure we type that in correctly. Yep. A company wants to determine the amount of Vitamix in the capsule. Okay, so this is just looking at what shape this is. So this is a cylinder. The cylinder is in the middle part, and then we've got a sphere that has sort of been separated. Half of the sphere is to the left side of the cylinder, and half of the sphere is to the right. The radius is 3. That's also the radius of the cylinder in the center. Okay, and then if you take 3 away from part of the sphere, you'll have 12 left in the front. And then if you take 3 away from the back, that would make 9 total for your cylinder. So it'd be 3 plus 9 plus another 3 gives you 15. So you have your 3 here and your 3 there. And so it's asking you, what does this really consist of? And so the cylinder actually is 9 millimeters. And so we want to select letter A, because that describes the picture to the fullest. Again, another population density. We're just going to divide, make sure we type it in correctly. So you have 308,745,538 people divided by our square miles, 3,531,905. And so we have, rounding to the nearest tenth, about 87.4 people per square mile. And just to point it out, if you're ever given people per square mile, okay, and you want to go the other way, you could do a multiplication. All right, so Jeremy wants to know the density of a rock in grams per cubic centimeter. What is the density of the rock? So we're just going to convert kilograms to grams, and then we're going to divide. Okay, so there are 1,000 grams in a kilogram. So we're going to first multiply 1.08 by 1,000. And that's just like moving the decimal over 3 times. So we're actually going to do 1,080 divided by 400. And that is our density in grams per cubic centimeter, 2.7. And I'm going to pause this video here and look out for part 2 for the last 7 slides.